Besides using the unit circle to go forwards, meaning if we know the angle, using the unit circle to find the sine or cosine or tangent ratio or the reciprocal ratios, we can also use the known ratio to figure out the angle. So in the examples that we have in front of us, we can see that we have the sine of the angle is known to be 1/2, or the cosine of the angle is known to be 1/2. And we want to know all of the possible angles between 0 and 2 pi, so one revolution around the circle, that have that trigonometric ratio. So to start off with, for sine of theta, we know that sine, of course, is the y-coordinate. We know that cosine is the x, and we know that tangent is the ratio of y over x. So in this case here, when I see that sine of theta equals 1/2, that means I know the y-coordinate is 1/2, so I need to look on my unit circle to see all the places where the y-coordinate is 1/2. And we can see that that's, of course, if the y-coordinate is positive, it's going to be in quadrants 1 and 2. And so the two locations that we have that are at pi over 6 and at 5 pi over 6. So at 30 degrees and 150 degrees. For the second example, now we want cosine to equal 1/2. So cosine, again, is the x-coordinate. So we look on the unit circle to see where the x-coordinate is positive. Well, that's going to be on the right-hand side of the unit circle, so in quadrants 1 and 4. And we can see that the x-coordinate is 1/2 at pi over 3 and then at 5 pi over 3. Again, we're just trying to find all the angles that are in this interval from 0 to 2 pi. Now for tangent, it's a little bit trickier because we're not just looking for a single coordinate, we're looking for the ratio of the two coordinates. Remember, tangent is y over x. So I need the tangent ratio to simplify into √3. Now the best way to think about this, √3 is greater than 1. So that means my opposite over adjacent is greater than 1, meaning that my y-coordinate has to be bigger than my x-coordinate. And so that's going to happen at 60 degrees or any angle that is coterminal with 60 degrees. So my answer for √3 being the tangent ratio is going to be pi over 3, so 60 degrees. And then tangent is also positive where either both coordinates are positive, like it is in the first quadrant, or both coordinates are negative, like it is in the third quadrant. Since negative divided by negative will equal a positive, and my tangent ratio is positive in this case. So therefore, my second answer in this 0 to 2 pi interval is going to be at 4 pi over 3. For cosecant equaling -2, we're much better off if we rethink this as sine of the angle has to equal the reciprocal, since sine is the reciprocal of cosecant. So I'm going to take the reciprocal of -2, and I get -1/2. So now I'm looking for where the y-coordinate on my unit circle equals -1/2. So that's going to be in the bottom half of my unit circle. So that's going to happen when the 7 pi over 6, and again at 11 pi over 6, when the y-coordinate equals -1/2. For the next one, we've got secant of theta equals -2√3 over 3. So I'm going to rewrite this as cosine of theta equals 3 over -2√3. And so then if I rationalize by multiplying the top and bottom by √3, we end up with cosine of theta equals, so we're going to get 3√3 over -2 times 3. So I can cancel out my 3's, and I can see I end up with cosine of theta equals -√3 over 2. So since cosine is the x-coordinate, I'm going to look for the x-coordinate equaling -√3 over 2. So we know the x-coordinates are going to be on the left side of our unit circle, and so we find that that's going to be at 5 pi over 6, and then again at 7 pi over 6. For cotangent equaling -1, so for us to end up with a ratio of -1, remember cotangent is going to be the reciprocal of tangent, so it's going to be x over y. And so to get an answer of -1, that means I need the same x and y coordinate so that when I divide, I end up with 1, but I need one of them to be positive and one of them to be negative. And so if we look at the unit circle, it's all of the 45s, or the over 4s, if you will, that we end up with the same x and y coordinate, but it's in the second and fourth quadrants where we have the opposite positive negative signs. In the second quadrant, we're negative for x, but positive for y. In the fourth quadrant, we flip it. We're positive for x, but negative for y. And so those two locations are going to be 3 pi over 4, where we've got root 2 over 2's for both the x and y coordinates, just differing in the positive negative sign, and then 7 pi over 4 is our other answer. For the last set, we're back to sine and cosine and tangent, so we're operating with just our y, x, and y over x ratios. And so we've got sine of theta equals 0, so we look to see where does the y coordinate equal 0. Well, that's going to be at 0, and then again as we rotate over to pi radians at 180 degrees. We won't list 2 pi in this case, even though that would be an answer that would have 0 as a sine ratio as the y coordinate, but we don't have an equal to sign in the set of values that we're reporting answers for. For cosine equaling -1, so now my x coordinate has to equal -1, so we can see that that happens on the left-hand side of our unit circle, so our only answer in this case is pi. And then finally for tangent, equaling 0. For us to get 0 as an answer, we need to have 0 in the numerator, meaning 0 needs to be the opposite side, or 0 needs to be the y coordinate. So I need to have 0, and then the only other coordinate we're going to have is either 1 or -1. And so if we look at those locations, the y coordinate equals 0 at 0, and then we also get that answer at pi. So these are examples of how we can work backwards with our unit circle. If we know the trigonometric ratio, we can find the coordinate associated with that trigonometric ratio and then use that to find the angle.